take some ready-to-use paste opaquer from the syringe or jar and mix. Apply a thin layer of wash material using a brush. Thus, the alloy is allowed to degas. The framework is adequately supported on the firing tray for each firing cycle. Subsequently, firing is conducted using the firing parameters for the first opaquer firing. The second opaquer layer is applied in such a way that the framework is completely covered. For a characterization of the opaquer layer, intensive opaquers may be used. After firing, the opaquer should demonstrate a silky matte gloss. For enhanced in-depth fluorescence, the opaquer F can be used. Either apply the opaquer F as a thin third opaquer layer and fire, or mix up to 20% of opaquer F with the conventional opaquer before the second layer is applied. The opaquerized metal framework is placed on the model. Weigh the ring base and note down the weight. Weigh the opaquerized metal framework too, and note down the weight. The weight is later used to determine the wax weight. First, the model die and the model are isolated in the cervical area with a stone wax separator. For crown and bridge frameworks, a retention in the area of the pontic has to be applied in the press-on metal technique. Here are some examples. Possibilities for a retention made of, for example, a wax wire with a diameter of 1 to 1.5 millimeters. Advantages of the retentions. 1. Ideal as cooling fins in the casting technique. 2. Retention of improved fixation in the investment material during the press-on procedure. 3. Handling aid for further processing. The retention should be carefully removed without overheating, not earlier than after glaze firing. The opaquerized metal framework is placed on the model. First, apply wax that burns out without leaving residue to the margins and check the fit. Subsequently, a fully anatomical wax-up is fabricated as for all ceramic restorations. The wax thickness of at least 0.8 millimeters is required for accurate outflowing during pressing. Contour the occlusal surfaces, shape, function, surface structure, shrinkage behavior as known from all ceramics. Check the occlusal contacts and proximal contact areas on the model in the stratos. Remove interfering irregularities. A wax wire of maximum 8 mm length and 3 mm thickness is attached to each bridge unit as a sprue. Sprues are best provided in a 45 to 60 degree angle at the thickest part in the direction of flow of the ceramic in order to ensure unimpeded flow of the press ceramic. Seal the opening of the ring base with wax. Weigh the ring base again and note down the weight. The wax weight is the total weight minus ring base and opaquerized metal framework. Choose the respective ingot size depending on the wax weight and restoration. Due to the two ingot sizes, unnecessary material waste is a thing of the past. With only 7 ingot shades, all chromoscope, A to D, and the bleach shades can be easily reproduced. Consequently, it is possible to press over different patient cases in one press cycle. The final tooth shade is achieved by individual characterization with the new shade, stains, and glaze materials. Carefully position the IPS silicone ring on the ring base. The silicone ring must sit flush on the ring base. Mix either the conventional IPS press vest or the speed investment material IPS press vest speed according to the instructions for use. Fill the cavity with a suitable instrument, and then fill the investment ring up to the marking. Attach the ring gauge and let the material set without manipulation. After the recommended setting time, remove the ring gauge and silicone ring with a turning movement and push it carefully out of the IPS silicone ring. Remove any rough spots and investment material residue and blow into the sprues if necessary. Position the investment ring towards the rear wall of the preheating furnace, tipped with the opening facing down. Choose the ingot size according to the wax weight and the desired shade. Remove the hot investment ring from the preheating furnace and insert the cold IPS inline palm ingots in the correct ingot shade facing upwards into the hot investment ring. After that, dip the cold IPS Emax Alox plunger into the IPS Emax Alox plunger separator and insert it into the hot investment ring. Place the investment ring into the center of the press furnace. Press Start. Place the hot investment ring on the grinding grid and allow it to cool to room temperature. The Alox plunger can be used to determine the length. Mark the length of the Alox plunger and separate the investment ring using a separating disc. For rough divestment, glass polishing beads at 4-bar pressure are used. For fine divestment, reduce the pressure to about 1 to 1.5 bar. Be careful at the margins and in the shoulder area. The pressed object can now be fitted to the master model and the proximal contact areas are ground in. The sprues are carefully cut above the attachment points with a diamond disc. Create the anatomical shape and the surface structure with recommended grinding instruments. Check the function, occlusal contacts and proximal contact areas in the stratos. If required, create contact points. Missing small areas and proximal contact points can be supplemented with the 7 touch-up add-on materials. The materials are mixed with the IPS Inline Palm build-up liquid until a creamy consistency is achieved. Apply touch-up materials in small drops and fire in the programmat. The surface structure is designed and growth lines are applied so that the light is refracted and reflected in different ways. The final tooth shade is achieved by individual characterization with the new shade, stains, and glaze materials. Dispense the desired amount of paste, shade, stains, and glaze, slightly dilute with the glaze stains liquid, and mix. Stains are used for characterization or to intensify the respective dent and shade. Add individual characterizations, such as discoloration and enamel stains in the interdental and occlusal areas. Afterwards, fire using the firing parameters for the stains and characterization firing. Apply glaze paste to the surface and fire. Final check of the shade, occlusion, and function of the restoration. Press-on technique for aesthetic and fast precision results. IPS Inline Palm.